Well, hey guys, welcome back to Last Stop Repair Shop. My name's Fran, and on this episode, we're going to show you guys how to test, troubleshoot, and repair the cruise control on your early model GMT400 pickup trucks. Could be the C series, the two-wheel drives, or even the K series, the four-wheel drives. Potentially even the 2500s. I don't know if those have the 700R4 tranny in them or not. But if your truck has a 700R4 transmission, that transmission's all manually operated. There's no electronics involved in the operation of that transmission. And so for that reason, General Motors, in their infinite wisdom, decided that we would do all sorts of signal conversion in the instrument cluster. Well, as you guys know, these trucks at the oldest are about 38 years old as the making of this video. So the electronics are giving out on them. There's just no way around it. So that's the issue we had with ours. Yours may not have that same problem. And for your sake, I hope it doesn't. I hope that part of it's working. We'll show you how to test it and see if that part of it's working, as long as, or as well as testing the servo, which is actually underneath the hood on the firewall that actually does the pulling of the throttle. We'll show you guys how to test that to see that that's working. We'll show you how to test the stick on the column to make sure you've got all the proper voltages you need for the servo to operate correctly. And then we'll also show you the signal and how to look for that to make sure you're getting the signal from your instrument cluster telling the servo what speed you're traveling at. That's how it regulates the speed, is it takes a signal from the transmission and that's converted in the instrument cluster and then sent to the servo. And that happens the entire time the truck's in motion. We'll show you guys how to test all that, how to simulate all that, and ultimately how to repair the cruise control on these trucks. Well, let's get started. Okay, so like always, whenever I get involved in something like this, I usually like to try to find, electrical prints or some kind of documentation, something that gives me a clue as to how the heck this thing works. Without any of that, you're really just throwing darts at a wall with a blindfold on, right? You don't have a clue what the heck you're doing, or at least I don't. So I like to try to go with documentation that I can find online. There's a lot of good information out there. If you just use the old Google and the digit box, you can definitely find some good information out there, which is where everything that I'm going to show you guys has came from. What I've got here is a manual that I located online. This manual here is specifically for the system we're going to mess around with here today. There is no reason to do a bunch of fussing and cussing about something that you don't know anything about, right? So this here is the actual Electromotor Cruise System Service Manual. I found this online. So it shows us everything about this system, how it works, what it's looking for, which is really handy. It tells you how it operates. I don't think we need to really go into all the operation of it here. I don't know if that's necessary. I'm pretty confident if you guys are, watching this video, you know how it operates. So what you're looking for is, how on earth am I going to fix the darn thing? Well, that's what I'm going to show you here. So there's the servo unit. They're calling it the cruise control module. Sure, we'll call it that. That's the unit underneath the hood that's actually doing the pulling of the accelerator throttle plate, technically, on the throttle body. So I'll show you that here in a minute. We've got one of them sitting here on the bench that we're going to use. Of course, there's the stick on the column I was talking about, your on-off switch, your push button for your set, and then, of course, your resume. And then we scroll down here a little farther. This here shows the internal transmission speed sensor. This is the guy that's actually picking up the speed in the transmission and sending it to the instrument cluster. So it works off of, I believe it's 40 teeth, if I remember correctly. There's a reluctor wheel inside the transmission that spins. It's a metal wheel that spins in front of this magnetic sensor, generating a sine wave signal. That sine wave signal, the range on it could be 0, right, if you're parked and not moving, all the way up to 128,000 hertz. So just kind of gives you an idea of how fast it can go. That's how far the range is. It's a huge range. I don't think you'll ever see 128,000 hertz. If you do, you are probably going to take flight in one of these vehicles. So let's not go that fast. But that's the range of the sensor. This is your brake light switch here. This is actually on the brake pedal arm, slid all the way up underneath the dash. The reason this is important is these contacts right here. Those are tied into that cruise control module. When you step on the brake, this is one of two switches that kicks that module out and shuts off the cruise control. All right, it's real important to know that. There's a switch here. There's another plunger switch here that's in front of the arm for the brake pedal. Those two switches are wired in series. So they want that circuit broke. They want that servo drive to shut off and kick out when you tap the brake pedal. So they didn't want to rely on just one switch to do it. They've got two of them in series. So this kind of gives you an idea of a block diagram of what's going on as far as what's all involved with the cruise control module. This is that speed sensor in the transmission I showed you, giving us a sine wave going to our vehicle's instrument cluster. There's some calculations and stuff going on. I'll show you here in a little bit. And then that comes out of all of that to a square wave, like so. And that square wave is 4,000 pulses per mile. Remember that. That's going to come up again and again later on in this episode. And then that 4,000 pulses per mile square wave is sent to the cruise control module, which through a cable pulls the throttle. I know, it's old school. The new ones all have electronic throttle body drive-by-wire. It's all done in the ECM, and just simply the computer tells the throttle body where to go, and it does it. Same as when you step on the pedal, it's all drive-by-wire. But this was just before all that stuff became popular. Remember, we're talking about a 1989 here, 37 years ago. So pretty impressive, to be honest, that it's even still functioning at this point. And then we've got some turn signal mode switches and stuff here. That's the switches on the column to turn this on or off, that set button, the resume button, all that stuff. That's what they're referring to here. It's kind of a diagram of what it looks like in the truck here. You guys get the picture. Again, if you're watching this video, y'all know where this stuff's at, so we don't need to go through all that. This kind of gives you a diagram of where that plunger switch is, right here in front of the brake pedal. The other one is slid way up in there. It is an act of Congress to get that switch in and out of there. Ask me how I know. I've had it in and out too many times to count already. But you've got to have it. And to get this plug on and off of there, it is a battle. I'm not kidding. It is a challenge. So here's the convenience center. I'll show you guys a picture of that underneath the dash in real time here in a little bit, so that way you guys have a better idea of where that's at. But that's down under the dash on the driver's side, all the way against the left-hand wall. So not hard to find. Here's that sensor in the tail shaft of the transmission that's picking up the signal for us. So that's pretty much it for that. This manual is a really good manual. Look this thing up online, get a copy of it for yourselves. It shows you how to troubleshoot everything. It gives you everything you need to know as far as which wires are doing what and all that. So I have another manual. It even gives you a diagnostic chart here. I have another manual that I think shows it a lot better than what this manual does. It shows us in color exactly which wire goes where. So it's basically a color version of what you're seeing here. So this is the cruise mode switch, your brake switches. If you drive in a stick shift, you could potentially have this in that truck. I've never owned one that has cruise control in it, so I'm not familiar with those, but according to the print, it is a thing, and some of you guys out there watching might well have one sitting out in the driveway. And if you do, it's basically the same as the automatic. You just have an extra switch in line here for the clutch. When you push the clutch in, it kicks off the cruise control. So here's that convenience center right here that I was talking about that's down under the dash. And then these wires here, which are leaving this way. You can see this was in a binder at one time. So this page would have been on the left side. This page would have been on the right. Here's our wires coming from back from the convenience center to the instrument cluster. That's that cruise speed signal out coming from the instrument cluster. Okay, so I think we're going to go ahead and flip over to this print here. And this print here shows us in color, really. It gives us the color of the wires, and it shows us where everything comes from and where it goes to. So the first one I wanted to highlight here is this one right here, the Speedo fuse. This is actually in the fuse box, hot and run. So when you turn the key on, this fuse is energized, right? This is in the fuse block. And so we have a brown wire with a white stripe, wire number 250. which powers the instrument cluster. All right, we're gonna have to return to this in the future when we get ready to start wiring stuff up on the bench here and showing you guys how to troubleshoot all of it, all right? Okay, so keep that wire in mind, wire 250. We're gonna come back to it in the future. So I always say, anytime you have electrical issues, the first thing you should probably look at before you start tearing everything apart and getting crazy is look at your grounding. Make sure you've got good grounding. Again, as I've mentioned, this is a 37-year-old truck, and I can almost guarantee you there's some rust on a truck in the Rust Belt, you know, in Iowa, Illinois, you name the state, right? If it snows, you guys up north, you all know the drill. We're all in the same boat together. Things rust, and one of the first things that goes out on us is our grounding, right? We lose our grounding on our chassis and things like that. So this chart here just kind of gives you an idea of the grounding for everything here. So instrument cluster, wire number 450 is a ground wire. That's going to be a black wire with a white stripe. The cruise control module out there underneath the hood, wire 450, it's the same ground wire tied to the same point. So it comes in through that convenience center underneath the dash, and it ties into this, I'm assuming this is internal to the harness. This S212 is actually in the harness itself. And then it comes down here to this S120, which I believe is also in the harness. And then it comes to this G107, which is going to be a body ground. It's one of the body grounds. So this truck has them, I believe, under the cab, left side, if I remember right, under the driver's door. There's some more of them, I believe, on the left side, behind the bumper, up underneath there, below the headlights, is some more body grounds. So I would check all of those and make sure those are good. I'm trying to remember where the other ones are at, just off the top of my head. I don't actually have it looked up, but anyway, make sure you check all the grounds. Make sure you got good, clean grounds. Start with that. Might be an easy fix. You can just pull those out, clean them up with a wire brush or something, and then slap them back on there on some clean metal, and you might be good to go. That might take care of the issue. It's entirely possible. You could also do an ohms check if you're not sure. Take a lead from the negative post of your battery, and then pull this plug off of the cruise control module, and you could ohm it, right? Ohm wire 450, or look for the black wire with the white stripe. It's really hard to tell. There's a brown one with a white stripe out there too. And I'm not gonna lie to you, if your eyes aren't that great, it's easy to confuse the two. So make sure you're on wire 450. It's a black wire with a white stripe, and you should be able to get low ohms. Ideally 1 ohm, 0 ohms, right? Do a continuity check. That would also tell you that you've got a good ground there, so you know you're grounded. And we'll show you that underneath the hood of the truck here. We'll show you guys how to check all that, make sure you're good to go. So that's your grounds. All right, the next place we want to head is page 78. Vehicle speed sensor, permanent magnet generator. Okay, so that sensor that we talked about in the transmission that's creating the sine wave, that 128,000 hertz or pulses per mile in this case, is being generated by this unit right here, okay? These are the gears in the transmission, and this is the armature, if you will, and your field coil. So as I've talked about in one of the other videos, if that one was released yet, I'm not 100% sure, at the timing of this video creation anyway, electricity is generated when you take a roll of wire or a winding and you pass a magnet past it. You're doing what's called cutting the lines of flux of the magnet is what you're doing. And when you do that, the copper wire or whatever conductive metal you have in the path of that magnetic field gets the electrons excited. So they bump into each other. The valence electron from one atom bumps into the one next to it. And they exchange those valence electrons. It's really science, to be honest. I think it's pretty cool. Who would think that science is really how everything works, but that's literally how it all works. So we're bumping one valence electron into another and pumping electrons, if you will, down the wire. So that's how it works. In this case, we're pumping those through this yellow wire and this purple wire into our instrument cluster, which is this big box right here. This is our instrument cluster. So that's what's in the dash. So we're pumping all of those electrons into here, 128,000 of them per mile, into this input buffer. We have a ratio adapter here. That's how we set our speedometer and all of that stuff. That's how we set all of that to the tire size, to the gear ratio of the rear end, all that stuff. So our miles per hour are correct. There are videos on how to correct your speedometer if it's off already on YouTube. It's something I could go into, but I think there's guys on YouTube that have already done a pretty good job of it. So just punch it in again, punch it into Google, and they'll pull it right up for you. Patronize those guys, watch their video. I don't want to take anything away from somebody else and steal their thunder. So for the purpose of this video, we're not going to get into how to recalibrate the speedometer, because that's really not in the scope of what we're trying to do here. We're trying to fix the cruise control. So speedometers being off, that's a whole nother thing. Go look those guys up and they'll get you squared away on that. It's pretty simple. It's not hard to do. So, all right, we come out of the ratio adapter here at 128,000 pulses per mile. All right. And then here we take those 128,000 pulses and we divide them by 32. That's where this 4,000 pulses per mile comes from. We also feed that to the odometer and the speedometer, okay? And then we feed that up here, back through that convenience center and out to our cruise control module, all right? We then take that 4,000 pulses per mile and we divide it by 2 again to send 2,000 pulses per mile to the ECM. And I believe ultimately this truck does have a crude form of anti-lock brakes on the rear wheels. It's also fed to that too, but for the scope of this video, we're not going to worry too much about that. Personally, I'm not a fan of anti-lock brakes on these older trucks anyway. I didn't think it really worked good even on the late models, and it's never worked on this early model, and I'm fine with that. I can pump the pedal, guys. I know when I'm sliding. I've been driving for years. I know when to let off the pedal. I'm not going to worry about it. So we just go ahead and not worry about all that. We don't need it. So the ECM, as far as I know, I'm sure it uses this signal for something, and I'm fairly confident we're not getting that signal either, but the truck runs fine. I don't have any problems with it. I'm not going to worry about it. Cruise control is what I want. I want that creature comfort, and so that's what we're going after in this video. All right, then I wanted to take a minute here to show you guys the wiring for the actual cruise control module. This print here kind of shows what's going on, all the voltages we need to be sent to the cruise control module, so which is down here at the bottom. So we start out up here at the top, hot and run. We turn the key on. We energize this fuse here in the fuse box, which energizes this pink wire with the black stripe on it. You got S202 here, which is a connection inside the wiring harness. It then goes down to that convenience center underneath the dash on the left side, next to your feet down below. Comes out of a plug down there. There's a 3-pin plug down there as a pink wire. In that wiring harness, there's a connection here, S230. That goes straight out to the cruise control module on pin F. It also, underneath your steering column, that same harness has another plug that's tied into the cable that comes from the switch on the column right here. So we've got a plug here. Inside that switch on the column, we've got the on-off switch here, represented by these two. It's actually the same switch. So when you turn this to on, you energize the green wire here in that harness from the stick, goes back to that same plug we talked about up here, and then becomes a gray wire. All right? So that gray wire, we have another connection in the harness, which then goes out to the cruise control module. That gray wire is also tied into that plunger switch and the brake light switch underneath the dash on your brake pedal. It leaves those as a brown wire here, wire number 86. Automatic transmission, it goes straight back out under the hood to terminal D at your cruise control module. Those of you guys who have the manual transmission on yours, That there is going to have another switch in series, which is then going to, the wire actually leaves the brake light switch as a gray and black, and then converts back to that brown wire 86 here. So those of us with automatic, well, you won't find wire 87. Those of you with the manual transmissions with cruise control will have this wire color here and another switch. All three of these switches are in series. So all three of those switches have got to make foot off the brake, foot off the clutch in order for us to get power to this brown wire. That brown wire is really important because that's the wire that is going to kick this unit off. If you touch that clutch or the brake pedal, this wire here has got to have power in order for this thing to function. If that wire for some reason is never energized due to one of these switches being flubbed up, that's it, it's curtains. It's never going to work. So it's real important to check that out. So back here at the stick on the column, we've got this to on. We've energized the gray wire. We have our set switch here, which is going to come out of the harness at the stick as red. At that plug underneath the column, it's going to turn blue and go out under the hood to the cruise control module. We also have the resume over here. These two are momentary switches, right? You can push the set switch, let off it. Same way with the resume. Slide that button to on and then all the way over to resume, and we'll energize this green wire. So it's really important to know this little secret, and this is one of the things that bit us in the rear end hard. That blue wire and that green wire cannot be energized at the same time. We replaced the stick on our column with the new one thinking we were doing ourselves a favor, and in reality the China switch, Malaysia switch, wherever it came from, it was not manufactured here in the US. When you'd push the set switch, both of these two wires would energize at the same time. When you hit the resume switch, same thing. Both of these two wires would energize at the same time. You're effectively trying to tell the cruise control to speed up and slow down at the same time. And that module says, no can do. And so it won't work. This was another one of the three problems we had going on with our truck. So make sure when we're out there testing it under the hood, make sure you guys are checking that. You know, you can check this wire here to ground, push the set button, and you should see voltage there as long as your finger's on the button. As soon as you take your finger out, the voltage should go away. And then repeat the test, but move your test lead to the opposite wire, to the green, and hit the set switch again. If that green wire energizes when you hit the set switch, guess what? It's not going to work. You're going to have to replace the stick. I took ours apart, and there was no way to fix it. I think it was just poorly manufactured, to be honest. I have no other explanation as to why it would have functioned the way it did. But I had a couple old steering columns around here. We ended up taking an old switch out of one of those steering columns, cleaning it up and putting it back on the truck for now, just to get it working in an effort to make it work. So yeah, it's a little disheartening. You spent, I don't know, those switches are upwards of 80 bucks, 150 bucks, depending on where you go to get them. I think we got that one off of the Rock site. Rock Auto, I believe, is where that one came from. I'm not 100% sure. It's been a year or two ago already since we changed it. But needless to say, it was money down the drain because it did not function correctly. It was for the right year truck. It was for that truck, but I don't know what the heck went on, but something went on in the manufacturing process that was not correct. So anyway, enough about that. Same thing with the resume switch here. If you hit resume, you should have power here only when you're holding that switch, that slider. You should never have power on the blue when you hit the resume. Same exact problem. If you've got power on that blue wire, when you hit the resume switch, it ain't gonna work. So we can't tell it to speed up and slow down at the same time. That's just not how it's designed to operate. So okay, so let's go out to the truck and let's go through testing all of this stuff so you guys can kind of get your eyes on it and see what it looks like out there on the truck. All right, so we're out here at the truck. Remember, one of the first things I said we should probably check is grounds. Wire 450 in this case is going to be the ground. That's that black and white wire, and it's really hard to tell, but I believe it's this guy here. So we're going to go ahead and probe that one. If you don't have a set of these, this is something that's really handy. So put this onto your lead, and then it gives you a really skinny skewer, almost, I guess we'll call it. It's basically called a back probe kit, and you can get into these tiny little plugs like this, and you can check it. So see there, we have 0 ohms. I got the other lead of this meter. I got it set to continuity. The other lead of it is over there on the negative post of the battery. So we have 0 ohms here. So we've got a good ground. Grounding is definitely not going to be a problem. So, all right. With that, we'll flip over to voltage, okay? So now, as we talked about earlier, the colors of the wires are very important. You can see, here's our pink wire. Remember, that one goes live as soon as we turn the key on. Here's our gray wire right here. Where's the gray wire come from? You guys remember? That comes from the stick, right? The on-off switch on the stick is where that one comes from. So as soon as we turn that on, this one should go live. And there's a brown wire that goes through your 2 brake switches. And if you guys got the manual, that's going through your clutch switch also. Remember, all those are in series. So if everything's happy under the dash, that wire should go live as well. All right? So I am going to go and probe the pink wire first. I'm going to go turn the truck on, and we're going to turn the switch on. Well, we're just going to turn the truck on, and then we should see voltage show up there. All right, what'd you guys see? Oh, 12 volts, 12.7, 6. The truck's not running, it'll drop off a little bit. So, okay, the pink wire went live. All right, the next one we want to check is going to be, I would say, let's check the gray. Gray comes straight from the on-off switch on the stick. You can see we don't have anything there now. So I'm going to turn the switch on. And what do we get? It went to 12 volts. Very nice. Okay, so that's good news. 12 volts, that's what you're looking for. So we should also have power on this wire here, provided our brake switches and our clutch switch is good. So it's going to be this terminal here. And we do. We got 12 volts there. If you touch the brakes, that wire will drop out, kicking this guy out, shutting it off. Okay, that's excellent. So we got everything we're looking for there. All right. So the other 2 wires that are left, well, there's 3 wires left. We got the blue, which is our set. We got the green, which is our resume. And then on this side, we've got that signal wire that's feeding our 4,000 pulses per mile. Show you guys how to test that here in a minute too. So let's check our set switch. We're going to plug it into the blue. We're going to hit the set switch. All right, what'd you guys get? I seen 12 volts. I think we're in good shape. Now, we have to repeat that test to make sure the green wire is also not being energized. That's what was going on with us. That was that problem number 2 or 3 I was talking about. I don't remember which one now. But it was one of those 2 problems that we created, right? We changed out the switch with the new one, thinking that we were helping ourselves, and really we hurt ourselves. So we're going to put this in the green, knowing full well we should never see 12 volts on this when we hit the set switch. When we hit the set, this wire should not go live. Yep, and it's not. That's good. That's what you're looking for. That had us caught up big time. And if any of you guys out there have ordered or bought one of those sticks recently, I would be willing to bet you've gone and changed the stick and it still isn't working. That's why, right there, because that's what happened to us. So make sure you guys check that, so that way you don't get caught up in the same thing we had going on. Now I'm going to hit the resume switch. I'm going to slide from on over to resume. We should get power on the green, but then we're going to go back to the blue and check it too, because we shouldn't have any power on blue when we hit resume. Only when we hit set. Let's see what we get. There you go. I seen 12 volts. That's good. When we hit resume, we should see 12 volts on the green. Now we go back over here to the blue, hit resume again. We got not to be seeing any voltage there. Yep, nothing. Okay, those are your voltage checks for this guy. So we know we have all the voltages doing what they're supposed to be doing here. The only thing left to check is signal. For my next act of stupidity here, we're going to attempt to recreate Ferris Bueller's Day Off. And jack this thing up, put it on jack stands, and while I'm not trying to wind the mileage back to you know, stop my parents from knowing that I was driving their car, what I am going to do, jack the rear end up and put it on jack stands so we can put this thing in gear and get the wheels rolling. So it'll generate our sine wave, which then gets converted to square wave in the instrument cluster, as I've talked about before, and then hopefully sent to our cruise control box. That's what we're looking for here. I can't think of a better way to do this or another way to do this. I mean, I guess you could pop the wires off the sensor and drive a signal into it there. But that doesn't really tell you the whole picture, does it? The sensor and the transmission could be messed up. It's possible. Chances are, if your speedo is correct, it's working, right? But what we don't know is the instrument cluster working? Are we getting that 4,000 pulses per mile that we need for the cruise control module to function? So that's what we're going to test here. Now guys, if you're going to do something like this at home, probably best to have somebody in the truck, a foot on the brake, you know, so they can stop catastrophe before it happens. Obviously jack it up on cement, level, right? Safety. Let's not be stupid about this and put something through the back of a garage. We don't need to recreate Ferris Bueller's Day Off. It's just not something we need to do. So I'm fairly confident if you're this far along in this project and still can't get it to work, you're probably going to be okay with doing something like this and not creating a lot of damage to the truck, the house, the garage, whatever, right? Neighbor's car down the street, you name it. So we don't want that to happen. If you are not confident you can do this without damaging stuff, don't do it. All right, just don't do it. There's no reason to. We got it on jack stands here, so it's not going to go anywhere now. All right, we're going to go ahead and head to the front of the truck, show you guys how to hook this up. And I know you guys are thinking, he's not going to start that truck. Put it in gear and let those tires spin wellest on jack stands. The answer is yeah, I am. I absolutely am. So, as I said earlier, safety first. Make sure you guys are doing this in a safe manner, okay? Let's be on cement, not dirt or gravel or anything like that, right? Let's be on a level surface. You can block the wheels if you want. All we need is an idle. We just need these wheels to roll. That's it. We don't really need it to do anything other than that. So with that, let's go ahead and commence the fun. So put your foot on the brake, put this thing in gear, and then ease off the brake. Let the wheels roll. All right. Automatics will roll about 10, 15, maybe even 20 mile an hour at an idle. So this one looks like it's doing about 9 mile an hour at an idle. Not bad. We can go with that. If you got a second person to stay in the truck to operate it, just in case something goes haywire, that would probably be a preferred method. I'm on my own today, so we're gonna just roll with it. If you remember from the print, the black wire here with the white stripe, that's our ground. We're gonna need a pin in that one. Doesn't really matter which one. We're dealing with an AC signal here, AC square wave. And then on the other side of the plug, the brown wire with the white stripe, that's where signal's actually coming from. Okay? going to need to probe that one. Turn our meter on to AC. This is an AC signal. Give it a minute to range. You can see there it's showing 6.9 volts, all right? If we hit the yellow button here, that sends us to hertz. We've got about 11 hertz on there. So that is proportional with speed. So if I reach over here and gets the throttle just a little bit, you'll see that increase. See it go up, and then it comes back down as it slows down. So that tells us that, well, it's working. It's doing what it needs to do. Show you guys the oscilloscope. Okay, I got the scope hooked up here. Make sure these wires are not touching anything. If you got to tape them off or whatever, you know, do what you got to do, but don't let those get grounded out. That could be a bad deal. Okay, so we're going to select oscilloscope here. This might be really hard for you guys to see, unfortunately. I am struggling this morning. Try to get this right up here where you can see it. Of course, we got glare to no end. Select oscilloscope, and there's your waveform coming off of there. We got to back it off a little bit. Just want to go this way. So we're changing the voltage range here. As you go up in voltage range, it looks smaller, right? Because you have more range to deal with. As the voltage goes down, then your waveform will look bigger, right? Because our window of what we're looking at gets smaller. So we can also change how much we're looking at. You can see there, you can see the, hopefully you guys can see that in the screen here. It's really hard to tell. But see that waveform going by. That's that waveform we were looking at earlier. I can't read it there. My eyes are not that good. Hopefully the camera's eyes are better. Shows the frequency there. It should be around 10, 11 hertz right over here. So now if I to step on the gas, increase our speed, that waveform should get shorter. See how it got shorter there? Hopefully without the glare you guys can see that. Anyway, that's how a scope works. It's supposed to be a square wave, but you can see it's not the squarest of waves, is it? No, it's kind of a wonky square wave, to be honest. It's not real pretty, but it's pretty enough that this thing is working. So that's all we need to know. So there you go. This truck has the 400 or 4,000 pulses per mile sent to the box. We've got all the voltages we need, so we should be good to go here. All right, guys, that's going to do it for part one of your GMT400 88 to 1990 cruise control theory, troubleshooting, and repair. We haven't really got to the repair part of it yet. That's coming in part two. We still got to show you guys how to test your servo or cruise control module to make sure it works. And then how are we going to fix the instrument cluster so it's giving us the proper signals again? We got those two things to go over yet. I wanted to break this into a two-part video just because it was getting way too long, trying to put it all into one. So with that, be looking for part two. Hey, we appreciate you guys watching. Hit that like and subscribe if you get a chance. Doesn't cost you a dime, right? And it's going to help out the channel. So we'll keep making videos like this as long as you guys keep watching them and find value in them. Thanks for watching. We'll see you guys later.